Hello everyone. I hope all of you can hear me properly. Okay, so you should be able to hear me right now. Uh, if you can, please say yes in the chat box. If you are able to hear me, please write yes or no in the chat box. Thank you. Okay, let's see. Okay, can you hear me now? Can all of you hear me now? Okay, great. Great. So, welcome to the first session or first workshop for the Bose Maths Olympiad. It's an online mathematics Olympiad that we will be conducting, that will be conducted by Chinta in collaboration with some other organizations, some schools all across the world. Uh, this is the first workshop for that, and the first hour of this workshop is for students of class 1 to 4. Okay. So this is just a free workshop to get you started off with number theory of Maths Olympiad. Okay. So for the class 1 to 4, this particular range, we will be discussing some properties of numbers, and our main goal will be to recognize patterns of numbers, recognize patterns of numbers. If we can do that, then we would be happy, because after all, one of the main goals of mathematics itself is to recognize patterns that are out there. So we'll start off with the simplest possible case, and that is a number pyramid. So I'll start with a pyramid of numbers. I'll start with a pyramid of numbers, and I will ask you to complete the pyramid. So the first 5 numbers are just 1, 2, 3, 4, 5. Okay. The first 5 numbers are simply 1, 2, 3, 4, and 5. Now, let me write the second piece of numbers, second collection of numbers. It's 2, 6, 12, and 20. 2, 6, 12, and 20. So you readily see a pattern. You readily see a pattern. The first layer of numbers is 1, 2, 3, 4, and 5. The second layer of numbers is 2, 6, 12, and 20. Okay, now let's go to the third layer. The third layer is given as 12, 72, 240. Third layer is given as 12, 72, and 240. Now, question is, what would be the fourth and the fifth layer of numbers? The fourth and the fifth layer of numbers. So we want to see this, we want to complete this pyramid. We want to complete this pyramid. And in order to do that, we need to analyze the pattern that is emerging from every layer. So the first layer is 1, 2, 3, 4, and 5. Okay, you look at the first layer and you think, what would be the set of numbers in the second layer, which is 2, 6, 12, and 20. Now you start seeing a pattern. In the third layer, the numbers are 12, 72, and 240. So what would happen in the fourth layer? Uh, so you can put, you can start trying this in your notebook. You can start trying this in your notebook, and then I'll be able to help you with some hints. Try to see some sort of a pattern between each layer of numbers. So if you, if I use a pen tool here, the first layer is this, the second layer is this. Okay, Arjun has some. So this is being broadcasted in three places. One is Zoom, and the other one is also Facebook, and there is YouTube. We are running this parallelly in all of these three channels, right? Okay, so I'm getting some answers both from Facebook and from Zoom. Pallavi is giving us answers in, and Meghana is also giving us answers. Okay, great. So some of you are recognizing this pattern properly. For example, if you take, let me change the color of my pen. Let's suppose it's in green. So suppose you want to find this number 2 right here. How would you find the number 2? Well, you multiply the numbers that are just below it, right? You multiply the numbers that are just below it. Similarly, you multiply these two numbers, 2 and 3, to get 6. You multiply 2 and 3 to get 6, right? Okay, so next thing you do is you multiply, okay, so maybe I can use a different layer. You multiply 6 and 12 to get 72. You multiply 6 and 12 to get 72. You multiply 12 and 20 to get 240. 12 and 20 to get 240. So you see how this particular thing is happening, right? At every layer, you find the numbers from the previous layer. You got the 12 by multiplying 2 and 6. So as many of you have rightly pointed out, to find this number right here, you have to multiply 12 and 72. You have to multiply 12 with 72. Great. Okay. To get the number in this particular layer, so this turns out to be 864, as many of you in YouTube and in Zoom are saying. This is 864, and then to get the number right here, you multiply 72 with 240, 72 with 240, if you multiply 72 with 240, and that would give you the product of I think 17,280. So that gives you this number here. And finally, the topmost number would be found by multiplying all of these four ones. So you multiply 12 with 72. So you multiply 864 right here with 17,280. 17,280, and you get the final number in the topmost box, which is 1492920. 1492920. Okay, so we have an idea about what's going on. We have an idea about what's going on. And we see that this number pyramid is, if you have seen Pascal's triangle before, this number pyramid is very, very similar to Pascal's triangle. Pascal's triangle uses addition. This number pyramid is using multiplication. It's a very simple problem to start with. I wouldn't even say that this is really Olympiad standard, but it's something to tell us that what's going on here. It tells us that if we have several numbers, there might be some hidden pattern in that sequence of numbers. And if we observe with all our intelligence, we should be able to recognize that pattern and maybe guess a next few numbers. All right. So I see that some of you are annotating in Zoom. So I would strongly recommend not to do it. Let's move ahead and go to the next problem. The next problem is known as the balanced ternary. The balanced ternary. Okay. So this is a very beautiful problem. Hello, Arush. Okay. So the problem of balanced ternary is one of the is a quite beautiful problem, and you will need a pen and paper for this. So you can grab a pen and paper if you don't have one. Okay. Let's try to do this. It's quite a nice problem. So it's again about recognizing patterns of numbers. Okay. It's again about recognizing patterns of numbers. So suppose you have three numbers, 1, 3, and 9. You have three numbers. So what you want to do is you want to create new numbers using these three numbers. You want to create new numbers using these three numbers, 1, 3, and 9. But there is a catch. You are only allowed to use pluses and minuses. So you put 1, 3, and 9 side by side. You can throw in a plus sign or a minus sign in between. That's all you can do. For example, we can have plus 1 minus 3 plus 9. We can have plus 1 minus 3 plus 9. This is equal to 7. Plus 1 minus 3 plus 9. That's equal to 7, right? So you are only allowed to use pluses and minuses to create new numbers. Now my claim is, you can also use none of the numbers. That's also possible. For example, it's not required that you use all three numbers. I could have used just 1 and 3. That's also okay. So one way to do it is, let's see, I could use plus 1 and minus 3. That's also possible. So then I would get negative 2, right? Now what I want is, can you express all the numbers from 1 to 13 like this? For example, I expressed 7 here. I expressed 7 here. 7 was expressed as 1 minus 3 plus 9. How do you express all the numbers from 1 to 13 using this method? You just need to use only three numbers, 1, 3, and 9. You are allowed to use plus signs and minus signs in between them. How would you express all the numbers from 1 to 13? So for example, 1 is easy. 1 is just 1. So you just use a plus 1, right? That's very simple. How can you use 2? How can you do 2? Can anyone tell me how to find out 2 using 1, 3, and 9 only? Excellent. So Nitya in Zoom is saying just use -1 and +3. Very good. Excellent. -1 and +3. How do you use 3? How to express 3? Well, you just use a +3. Forget about everything else. How do you express 4? How do you express 4? Again, you can only use these 3 digits: 1, 3, and 9. You are only allowed to use these 3 digits, 1, 3, and 9. This time you are using, okay, Arjun in Zoom is saying this is easy, +1 +3. How would you express 5? How would you express 5? Excellent. Shweta, Pallavi, Roshan, these people are, well, Pallavi's answer is a little off, but the other people's answers are quite nice. So this is -1, -3, +9. -1, -3, +9. So this is 5. How would you express 6? How would you express 6? -1, -3, +9. That's 5. How would you express 6? Excellent. That's -3, +9. Very good. That's 6. How would you express 7? How would you express 7? So like this, can you express all of them and put it in the chat? 7 would be, you again, you can only, so Rashmi, remember, you can only use, you cannot, Dinesh, you cannot use 2 3s. You can only use 1 3. You can use 1, 3, and 9, and each of these digits can be used only once. Excellent. Shweta and Nitya has the correct answer for 7. 7 is +1, -3, +9. So Dakshayani is saying that, okay, that's very good. Yes. Also has the correct answer. So Shashikala, we cannot use -2 because 2 is not in this particular sequence. Yes. 2 is not here. Only 3 numbers can be used: 1, 3, and 9. Nothing else can be used. Only 3 numbers can be used: 1, 3, and 9. That's it. Okay, how would you express 8? How would you express 8? 8 is a funny little number. Yes. So Roshan and Arjun has the right answer already. Roshan and Arjun has the right answer already. Very good. Excellent. So 8 would be, so maybe I can change the color a little bit. So 8 is simply -1, +9. 8 is simply -1 and +9. So try to, so 9 is 9. There is no problem with 9. 10 is +1 +9. How would you express 11? How would you express 11? So some of you are already giving me answers for 11. That's excellent. I would really, so since we have given so many examples now, I would request the others to actually try this. Try to express 11. So for 11, you can just simply do the following. So maybe I can put it here. So for 11, we can simply do +3 +9 -1. For 12, we can do +3 +9. And for 13, we can add up all the numbers 1, 3, and 9. It's quite simple. Okay, so now we are ready to do the next one. Suppose we also have a number called 27. So earlier we had 1, 3, and 9. Earlier we just had 1, 3, and 9. Now suppose we also have 27. We also have 27. So how would I go about that? What up? So earlier I could make numbers up to 13. For example, I cannot make 14 with 1, 3, and 9. You can check this. You can check that I cannot make 14 with 1, 3, and 9. So this is not possible. But if I add a different number called 27 in the mix, so now I also, if I have 27, maybe I can put it here. 27. Now I can make 14. Up to what number can I make if I also have 20, if I'm also allowed to use 27? If I'm also allowed to use 27, up to what number can I use? So we are getting some answers. We are getting some answers. Some really nice answers are there, of course. So this is one of the challenge problems that I will ask you to do. It's a very, very nice problem, in fact, that try to express all numbers up to 40 using 1, 3, 9, and 27. 1, 3, 9, and 27. So now, once you're done with this, you can just send us a particular solution using email, and you can send it to us at support@chinta.com. Support@chinta.com. Okay. That's a simple enough thing to do. Okay. Now, before we proceed further, let me announce this a little bit. I'll share the proper screen with you so that you can see it. Let me just okay. So let me share the screen quickly and explain to you one thing about the upcoming Bose Math Olympiad. So perhaps you are already familiar with Chinta, the the organization that I represent. So this is an online Maths Olympiad, and it will be starting in the month of July. So this is the first workshop for that. From 6 p.m. we have the workshop for 1 to 10 fourth graders. From 5 to 8 we have from 7 p.m. So it's coming up next. And you are actually attending the boot camp. So I would recommend you to go to chinta.com/bose to actually attend the seminar, attend the Math Olympiad. Okay, so I'll just put it here, put the link on both Facebook and Google. Let's see. So yeah, this is the name of the Olympiad, and I can also put it in the chat so that you will be able to see it. So this is, let's go. So you can submit the homework at support@chinta.com. And if you are an existing student of Chinta, you can register. Or if you are not an existing student of Chinta, You can always register for the program here, for the Math Olympiad. So you can click on institutional register or student register to do the registration. Okay. So this will be a 2-round Maths Olympiad. Students from all over the world will be attending this. So it's a very good test for your mathematical skills, and the things that we will be learning from the workshop can be directly used there. Of course, you can enhance much of your skills using the Math Olympiad program that's also conducted by Chinta. Anyway, so let's move ahead, and let me just okay, let me just share something else with you. Okay, so let me share the. Let's stop sharing here. Okay, so all right, we are now back at the screen. We are now back at the screen that we were supposed to be in. Okay, so we were working with this balanced ternary for a few moments ago, and we will continue doing that. So nothing is free, Asha Pandey. The registration for the Math Olympiad is free, of course. Yes, the registration for the Math Olympiad is free, if you're asking that. All right. So yes, the course is not free, but the contest is free to attend. Sure. Okay. So all right. So coming back to this, we discussed a little bit about the balanced ternary and the way we can do this using three numbers 1, 3, and 9. Now, if we are only allowed to use 1 and 2, 1, 2, and 4, let's say, so maybe I can just change the then let me use the pen tool here. So if I'm only allowed to use 1, 2, 4, these three numbers, if I'm only allowed to use 1, 2, and 4, how many numbers can we make? Will the same trick work? So for example, can I make all the numbers from 1 to, let's say in this case, 7? Is it possible to make all the numbers from 1 to 7 using these three numbers 1, 2, and 4? So if it works with 3, is it possible to do the same thing with 4? So if you know a little bit about the how powers work, you can readily see that okay, these numbers here, 2 is 2 to the power 1, or it's 2 2 multiplied it with itself 1 times. 4 is 2 times 2. As I said, Arush, the Math Olympiad is free of cost, but the course has a price tag. So you can just go to our website and register for it. Okay. Okay. So this is 4 is 2 times 2. So is it possible? Is it possible to yeah. So is it possible to uh, create all the numbers from 1 to 7 using just 1, 2, and 4? So Arjun is saying yes, of course. 1, 2, 1 plus 2, 1 plus 2 plus, so 4 itself, 1 plus 4, right? So that's 5. 6 is 4 plus 2. And 7 is 1 plus 2 plus 4. Now, do you see a very interesting thing? There's a difference between what we just did uh, from a moment ago. This time we are only using pluses and we are not using minuses. We are using 1, 1 plus 2, 1, then 2, then 1 plus 2, then 1 plus, then we just used 4, then we used 1 plus 4, then we used 4 plus 2, and then we used 1 plus 2 plus 4. So there is a difference between how threes are working and how twos are working. When I'm using twos, then I'm allowed to use both. I'm just using pluses and it's all working out. When I'm using threes, I have to use both pluses and minuses. Otherwise, it's not working. So can you check whether this pattern sustains for even higher powers of 2? So for example, instead of 1, 2, and 4, if you add 8 to the mix, or if you add 16 to the mix, can you create all the numbers using just plus signs from 1 to whatever the sum of all the numbers are? Okay, so give it a try. This is a very powerful area of mathematics where you create new numbers using existing numbers. We will meet again next week and we will announce the timing and everything. But till then, keep on doing great mathematics and we will see you again on the next chat. Okay, bye and stay safe in this time of COVID-19. Take care.